Okay, I hope I'm live now. Can someone let me know in the chat if I'm live? Okay, yes, perfect. So I'm going to be upsolving Codeforces Starters 2020 rated for Div-3. It's a new round and it happened yesterday. Okay. So, and it has 6 problems and we are going to be upsolving all the 6 problems of this contest today. So I can see the first 3 problems are very easy. Then the fourth one is okay. And then the last two might be a little difficult. Let's see what happens. Hello, so yes, we have Rahul and Dipankar saying hello. Hello, Rahul. Okay, cool. Let me just set up a few different things first. Okay, this. Okay. Attending the conversation, solve first three. Okay, okay, Dipankar, we are going to be solving the rest of them as well today. Okay, just setting up a few different things first. Okay, cool. Okay, so let's start. I'll remove these problems from the previous stream first. Okay, so please start from last question. We are actually going to be starting from the easiest problem first because I think that's what most people would like to know. But don't worry, like the first 4 5 problems are not going to take much time, I think. Okay, let me pass this and this. Okay, cool. So the very first problem is chef on island. So the problem says that suppose chef is stuck on an island and currently he has X units of food supply and Y units of water supply in total that he could collect from the island. He needs XR units of food supply and YR units of water supply per day at the minimal to have sufficient energy to build a boat from the woods and also to live from another day, assuming it takes exactly 3 days to build the boat and reach the shore. Till whether chef has the sufficient amount of supplies to be able to reach the shore by building the boat. So the problem is very simple, I think. We just have to divide this x by xr, this xr, sorry, he has this x by xr and see if that is greater than equal to d because that is the number of days he is gonna survive for the food and the same for y as well. So let's just submit it in a minute. Cool. The code for this problem is CCISLND. Okay, cool. Okay, okay, cool. So we have t number of test cases in the start. Let's, okay, we have while t minus minus and then we have int. Okay, so first we have x, then we have y, and then we have xr yr. Okay, we have x, we have y, we have xr, we have yr, and we have d. Let's scan these x, y, xr, yr, and d. Okay, cool. And now we need to check if, okay, we need to check that if x upon xr is greater than or equal to d and sorry, yeah, d and y upon yr is greater than or equal to d, sorry, greater than or equal to d, then we can say that he's gonna be surviving it. Okay, else it's cout. No, let's just compile this and then submit. Okay, we have everything. Let's submit it. I have Shakir asking, so what about RBI sir? He's fine now? Yes, yes, Shakir, he's fine now. He'll be back soon. Okay, okay, correct answer. Okay, let's move on to the second. Okay, before that, I would actually like to show everybody what Unacademy has to offer all of you. So let me just open that. Okay. So this is a little bit about me. I am working as a software development engineer at Adobe. Before this, I was working as a member technical at DShaw, and I'm a candidate master on Codeforces and 5-star on CodeChef. On Academy, I'm actually teaching competitive programming, things related to data structures and algorithms, and I'll also be uploading some videos related to interview preparation. Okay. Now let's come on to Unacademy subscription. So Unacademy has a subscription. These are the various price ranges for the subscription, and the things that you're going to get in this subscription is we are going to be having live interactive classes in which you will be able to attend live classes from the top educators. The people are like Red Coders, and we also have ACM ICPC finalists as well. Okay. Apart from this, we'll be giving you a curated set of problems from CodeChef as well. Apart from that, we have doubt support so that you are not stuck on any problem at any time. So these are the various payment methods, and also apart from this, you can actually use my referral code. The code is N by VT. You can write it down, and by using this referral code, you are actually going to get 10% off on any subscription plan. So I think that's it about this. Now let's come on to the second problem. Okay, let me open the chart as well. Okay, okay. So we have a company conducted a coding test to hire candidates. N candidates appeared for the test, and each of them faced N problems. Each problem was either solved by a candidate, solved partially, or solved completely. Okay, just a second. Okay, cool. To pass the contest, each candidate needs to either solve X or more problems completely, or solve X minus 1 problems completely and Y or more problems partially. Okay. Given the above specifications as input, print a line containing n integers. The ith integer should be 1 if the ith candidate has passed the test, else it should be 0. Okay. So basically what this says is, let's say we have 5 subjects and there are 4 students. So the first student, these are not subjects actually, these are I think questions. We have, yeah, these are M problems. So in the first problem, the first candidate was able to solve it completely since it is full. U stands for unattempted and F for full, and then P for partial. So what they're asking us is that we are given this 3 is X and this 2 is Y. So basically what they want is if a user, if a person is able to solve greater than equal to X problem, then what is he? He's able to pass, I think. We have, okay. Yeah, he's able to pass. Or if he's able to do x minus 1, sorry, this if, and this count of f is greater than x minus 1, and if partially count is greater than equal to y, then we can also say that the candidate passed. So we just have to write the code for this. It is very straightforward. Courses of CP. Yes, Krishna, the courses of CP. Okay, sir, where is Jay sir? Jay sir is also having like uploading videos. I am sure you are able to see his videos as well on this channel only. Okay, so let's write the code for this problem. Okay, so let's have the template. So we have t number of test cases first, and then we have for every test case we have n people and m problems. So let's scan these as well, and then we have X and Y. So let's scan X and Y as well. Okay, so now for every candidate, okay, and for every problem, sorry, so we have j equals to 0, j less than m, j plus plus, and then we'll just see in a character. Let's say this character is temp, and let's initialize this declare this character as well. So temp char, if temp equals to f, then we have full plus plus. If this temp equals to p, then we have partial plus plus, and let's have full and partial as well. So full equals to 0 and partial equals to 0. So we have the count of full and partial, and now we need to check if full is greater than equal to x, or and now we'll have okay, we'll first check if count of fill is greater than equal to x minus 1, and if the count of partial is greater than equal to y, then also we can say he will pass. So for pass we have to print 1, else we have to print 0, and after that we'll have a new line for every test case. Let's compile this. Okay, we have an error, so space, okay. Okay, we have the perfect answer for every test case. Let's submit this. Okay, so C++ 17. Okay, if anybody is having any problems in the first two problems, they can let me know in the chat. I'll just show them again. I feel these are very easy problems, so I'm not wasting much time on these. And we have a correct answer for this as well. Let's jump on to the third problem now. That is thief and police. Okay. Okay. The statement is a little longer. Okay. So there is a n by m grid. A thief is trying to escape from a policeman. The thief is currently in a cell xy in the grid, while the policeman is in cell AB. Cells are numbered from 1 to n, top to bottom, and 1 to okay, standard. Okay. Both of them are at different cells initially. Okay. Both of them take turns alternatively. First, it is the thief's turn, then the police's. Okay. The thief needs to reach the cell nm to escape. In his turn, the thief can move either right or down from the current cell. Okay. So, thief can move either right or down. Okay. He needs to move during each of his turns. The policeman can move right, down. Okay. And same for the policeman, or right plus down. Okay. So a policeman can actually move right also, or down also, or he can move diagonally as well. Okay. It is not compulsory for the policeman to move every turn. Okay. He can choose to stay in his current cell in a particular turn of his. Okay. None of them are in cell NM at the start. Okay. The policeman catches the thief as he is in the same cell as the thief at any point of the time, and he has reached that cell before the thief. If the thief reaches the cell NM before the policeman, then he shall escape. Find if the thief shall escape or the policeman shall catch him if both of them move optimally and if both of them have perfect knowledge of other person's location at all times. Print yes if the thief shall escape, else print no if the policeman shall catch him. Okay. So the problem says that, let's say this is a grid of n into m. I think it's n into m. Yes, it's n into m grid. Let's have a grid of 5 cross 5 only for now. This is the endpoint. Let's say the thief is at this point and the policeman is at the very start. And now we need to see if this policeman is able to catch this thief. Okay. So what is the best way to do this? Now we know that a thief can move either on the right direction or on the down direction. A policeman can move either on the right direction or on the down direction or in the diagonal as well. And the motive of the thief is to move till the end so that he can escape. and the motive of the police is to catch the thief. So let's see, can someone in the chat tell me what we should do right now to ensure that the police is able to play optimally? Okay. Okay. So in order to do this, now we know that the thief actually wants to reach the end, and let's say, uh, so we can actually calculate the time this thief will take to reach the end. And now we know that the thief will take, let's say, X amount of time to reach end. And now we can try to calculate the time that P will take to reach the end as well. And we can just see if the police is able to reach the end before thief. If he is able to reach before thief, he can just come here, stay here till the thief comes, and then he can catch the thief. Move to end as quick as possible. Yes, Vishal, exactly. Okay. So, and we are given the coordinates of both of them. So let's say in the very first example, let's see. So we have, let's see some examples for this one. So we have a 3 cross 3 grid. Okay. So and the coordinates, first we are given the coordinates for, okay, input says the first line of each section contains NM. Okay. Okay, the first coordinates are for the thief. So we have a 3 cross 3 matrix. Then the thief is at 2 comma 3. So let's see where is 2 comma 3. So 2 comma 3 is this, and the goal is to reach this point. Thief is at 2 comma 3 and the policeman is at 3 comma 1. So 3 comma 1 is actually this point. Let's see how much time the thief is able to take to reach the end. So the thief can just move down, and by this we can say that the time for thief will be 1 second, and the time for police will be, so he only has one option, and that is to move right. So one move right and the second move right. So police is going to take 2 seconds. Now since the time of P is actually greater than T, greater than or equal to actually, because we need to ensure that the police reaches at the end before thief. So what we need is actually P should be less than T. Now, but since P is greater than or equal to T here, therefore the thief is able to escape, and the answer for this example is yes. Let's see the second example. Okay, so the second example is 3 cross 3 only. So we have a grid of 3 cross 3 again. Okay, and the thief is at 2 comma 3 and the policeman is at 3 comma 2. Okay, policeman is here, and let's see. So basically in this as well, so the thief will take 1 second and the policeman will take 1 second. And since now again P is less than T, this is false. Therefore the thief is actually able to escape again. So the answer for this will be yes again. Now let's come on to the third example. And the third example has a grid of 5, the grid is 5 comma 4. Okay, so we have 5 rows, first row, second row, third row, fourth and fifth. Okay, and 4 columns. This is the end, and the thief is at 1 comma 2, that is actually this, and the policeman is at 4 comma 2, 4 and 2. Okay, police is here. Okay, so let's first see how much time this thief is actually going to take. So this thief is actually 1, 2, 3, 4, 5 and 6. So basically the time for thief is going to be 6. Now the way I've actually calculated is, we just have to find the absolute difference of the x coordinate of this T and the endpoint, and the same for Y, and then we just have to add them. Since he's actually able to decrease this distance from the endpoint by 1, either in the horizontal direction or in the vertical direction. Okay, cool. So the time for the thief is going to be 6. Now let's see the time for P. Now we know that he can either move in the right direction, or he can move in the down direction, or he can move diagonally as well. So if we see, the shortest way for him will be to move diagonally first. So we'll make him move diagonally, and now the policeman is at this position, and now he can just move in the right direction. So the time for policeman is actually 2 seconds, and as we can see, P is less than T, therefore the thief will not be able to escape, and the answer for this will be no. Okay, so the only thing that we have to calculate is the time for both the police and the thief. So for calculating the time for thief, it is very straightforward that we just have to find the absolute differences between the x and the y coordinate. But what about p? Let's have a few examples to see how much time p takes. Let's say p was somewhere here. If p was here, his best way would be to move a diagonal here, then move a diagonal here, and then down. Let's say what happens if p was here. Now, his best way could have been a diagonal here, then a diagonal here, and then a diagonal here. So basically, let's say we were, and what if we were here? We have to move three rights, sorry. So basically what I'm trying to prove here is we need to first take the diagonal direction as much as we can, because the diagonal direction is actually decreasing our distance one times in the horizontal direction and one times in the vertical direction. Therefore, taking a horizontal direction whenever possible is the best way. So we'll first try to take all the horizontal directions, and then we'll either move in the right direction only or we'll move in the downward direction. So let's try to code this now. I hope the approach is clear to everybody. If someone has any difficulty in understanding this, they can let me know. I'll explain everything again. For the time being, I'll try to write the code for this one. Okay. I hope this is tandp only. Yeah, tandp. Okay, cool. Okay, so we have t number of test cases first, and then we have n and m. Okay. Okay, and then we have coordinates for thief and police. So let's say the coordinates of thief are tx and ty. So just scan tx and ty. Then we have the coordinates for police. So we have px and py. Okay, and these are px and py. Okay. Now let's calculate thief distance. Thief distance is actually nothing but, so we know that the endpoints are actually n comma m. So the distance for thief is going to be, so the distance of thief distance is actually going to be, so we have n number of rows, so this will be n minus x, since the row number for this thief is actually x and y, and then we'll add m minus y to this. So the distance is actually going to be n minus tx plus m minus ty. Now let's calculate the distance for police. So police distance. Now for police, we will actually have to first find a couple of things. So we'll first have to find how many diagonals we can move. So in order to do that, diagonal moves. Now these are actually going to be the minimum value of the rows left and the columns left. So this is actually going to be, okay, so this will be n minus ty comma m minus ty, and okay, and then we are actually gonna increment tx by diagonal moves, since this will be the updated position for him, and then we are actually going to be updating ty as, this has to be py, since we are calculating for police, and here also p. Okay, p. Okay, so we have py plus equals to diagonal moves. Okay, cool. So now the police distance is actually going to be diagonal moves, since these are the number of times we can move in the diagonal. Diagonal moves plus the same thing, this n minus control C, control V, and we have px and py. Okay, and now we are just gonna check if police, police distance dis- dis- distance is less than thief distance, then we'll print no, since the police will catch him, or else we'll say yes, that the thief can escape. Let's compile this. Okay, so we'll compile this now. Okay, there seems to be something wrong with the code. Just a second. Okay, so the issue is actually we didn't move inside while t minus minus. Okay. Okay, so let's compile this now. So we have no for everything. Let's see the mistake. So we scanned NNM. Okay, we have txty, txty. Okay, we have pxpy, we have pxpy. Okay, okay. Then thief distance is n minus tx, perfect, and m minus ty, perfect. Yeah, okay, perfect. This is right. Then we have diagonal moves, which are actually minimum of n minus px. This is the mistake. N minus px, m minus py. Okay. And we have the right answer for this test case. Let's try to submit this now. Okay, we have the right answer. Let's move to the fourth problem now, that is maximum size, and I can see that the number of submissions gradually decrease here, so I think this will be a little difficult than the others one. Okay, I hope the explanation for the third problem is clear to everybody. Can someone in the chat let me know about this? And then we'll move on to the fourth problem. Okay. Clear. Okay, Vishal says clear. Perfect. Let's move on to the next problem. And the next problem is just a second. Okay, I hope you can see the board now. Okay. So the next problem is Chef is playing an easier version of the board game Risk with his friend Mike. There's an end-to-end grid depicting the world map. Each cell of the grid is either 1 or 0, where 1 denotes that there is land on the cell, while 0 denotes water. Okay. In a turn, a player can capture an uncaptured cell that has land and keep capturing neighboring cells that share a side with it if they are on land. A cell once captured by a player cannot be captured again by another player. The game continues till no uncaptured cell has land. Each player wants to be in control of as many cells of land as possible in total when the game finishes. Find the maximum number of cells of land that Chef can capture if he plays second and both players play optimally. Okay, cool. So the problem says that we actually have a grid of n cross m, and we need to find islands on this. By island, what they mean is, so if we have consecutive ones on either on the which are actually stick with each other from the size, then that is an island. So we have, let's say in the first case, we have 1 0 0 1, we have 0 1 1 0, we have 0 1 1 0, and we have 1 0 0 1. So in this, we can say that this is one island, This is the other island. This again is one island. This is one island, and this is one island. So, okay. Rahul says that, sir, explain distance finding. Okay, let me just do that again. So, as you can see, so for thief, this is actually n minus tx, but since we need to move, n minus tx moves in the horizontal direction in order to reach the end, and m minus 2y moves in the vertical directions to move in the end. And since the thief was only able to move in the in the right direction or the down direction, these are the only two things that we need to consider. Now let's come on to the police. So a police can move diagonally as well, and if we see, a diagonal move is nothing, a right plus down move. So now if we see that, so basically we can obviously say that a diagonal move is obviously the optimal move. So whenever we are able to move a diagonal move, we need to do that. Now in order to calculate diagonal moves, we need to ensure that we have a cell on the diagonal, and in order to do that, we need to first see that we can move one times in the right direction and one times in the down direction. And for that, all we just do is we actually find the minimum of the number of moves you can move in the right and the number of moves you can move in the downward direction. Whatever is the count of this minimum value, these are the number of diagonal moves that we can do. Now, what we do is we actually update the position of the police after all the diagonal moves. So now the updated the updated coordinates become px and py. Now we know that these are the diagonal moves that he needs to make. Apart from that, we have exhausted the diagonal moves. Now we can either move in the right direction or in the downward direction. So I just use the same logic that we use for thief distance, and I just copy pasted it here with the coordinates for the police. And this is how the distance finding is done. I hope it's clear to you, Rahul, now. So we'll just jump back to the fourth problem again. And the problem, okay, so we had we can see that we have 5 islands, 1, 2, 3, 4, 5. Now we know that both of them are playing optimally. So we have two players, one is Mike and one is Chef. And okay, who plays first? Okay, and both the players are playing optimally. Okay, a player can capture. Okay, the game continues. Find the maximum number of cells land that Chef can capture if he plays second. Okay, Chef is playing. So Mike is playing first, and the Chef is playing second. So now we know that both of them are actually playing optimally. Now, since both of them are playing optimally, Mike will obviously take the island which has the maximum number of cells, which is this one. So Mike will take this one. So let's say this is Mike, and now it will be Chef's turn. Now he's left with 4 islands of 1 cell. So we'll take any of these islands. So let's say this is C. Then Mike will take any of these. Then we'll have Chef, and then we'll have Mike. So now if you see, the total number of cells that Mike has are 1 plus 4 plus 1, that is 6. And for Chef we have 1 plus 1, that is 2. And hence the answer for this particular case is actually going to be 2. Now let's look at the next example, that is 1, 1, 1, 1. Okay, so we have 1, 1, 1, 1. So we can say that this is actually a complete island only. And since Mike was actually playing first, Mike will take all the 4 islands or all the 4 cells, and Chef will be left with 0 cells, and hence we have 0. And in the last test case as well, as you can see, we have 3 islands. One is this lone island, then we have 1 island here, and then we have 1 island here. Okay, and since there are 3 islands, the first island will be taken by Mike, then we'll have the next island taken by Chef, and the last island will be again taken by Mike. So in total, Chef will have 1 island only. So the answer is 1. So can someone in the chat let me know the approach, the basic approach that we are going to have for this particular problem? Okay, so let's move ahead with the code. So basically, what we need to do is we actually need to find the size of the islands. We need to find the size of the islands, put them in a vector, and see. So basically, we'll sort the size of the islands because Mike will obviously take the biggest island first, then Chef will take the next biggest island, and then the chef will take the next to next to next biggest island, and so on. So what we need to do is we actually need to find the size of all the islands, put them in a vector, sort them in the reverse order, and then we just have to give every alternate value to chef. And in order to do that, we actually need to either use BFS or DFS. So okay, so let's do that. Now, in order to find the islands, we'll actually have to use Q, and this problem is also known as multi-source BFS. So if someone wants to get a better understanding, they can also Google this. I'll try to explain the approach now. Okay. So what we are going to do is, let's say we catch this island first. We come onto this cell, we see that this has 1, that means there is land and we can have a potential island here. What we do is we actually move in the right direction and in the downward direction and see if do we have any other cells which are 1. Now since there is nothing, we just do nothing and say that we have an island of size 1. Let's say what happens when we are onto this one. When we are onto this one, we move on the right direction and we move in the downward direction. We see that the value on the right is 1 and the value on the down is also 1. Now we actually ask 1 to move in the right direction and in the downward direction. This 0 is 0, therefore we do not move ahead. But this 1 is 1, so we count this as well. Now this one comes and says I'll move in the right direction and I'll move in the down direction. For down direction, it says that I have a 0, therefore we won't count this. And in the right direction, he sees that the above one has already processed this node, therefore it doesn't process any node. And this is actually known as BFS. So let's write the code, and the things will definitely get better in the code. So let's see that. Okay, so we have t number of test cases. After that, we have t minus minus, and then we have n and m. Okay, n. Okay, and now we need an array of size n and m to scan everything. Okay, now one thing that we are actually going to do is we are going to have an array of size n plus 2 and m plus 2. Now the reason for doing this is actually we'll actually insert a layer of water around this grid. Now the reason for doing this is we actually never have to check if we are in the bounds of the grid or not. We can just move ahead, see that it is a water, and we can cancel our recursion. Okay, cool. So we'll first have everything filled with 0. So we'll fill everything with 0. Okay, size of array. Cool. And now we are actually gonna scan everything. So for scanning, 1 from 1. J less than equals to m and j plus plus. Okay, and we'll just scan every value. Now if you see in the very first test case that this is 1001 and scanner will actually take this as 1001 as an integer value. So in order to save us from that, we'll just have a char temp. We'll scan this character and then we'll actually assign the value to array ij. So array ij will actually become temp minus 0. So basically this will actually take the sky value of temp, which for 0, and since we have 0 here, so 0 minus 0 will become 0 and 1 minus 0 will become 1. Okay, so we have the input here. Now we'll have a visited array as well. So let's make it n plus 2, and let's fill it with -1. Size of VIS. So I don't think there is much about the approach here. It's all about implementation. So okay, now we are going to go at every cell I plus plus. Then we have for int j equals to 1 less than equals to m j plus plus. Okay, so if this is an island, so we'll just say that if array I j is an island, then we'll first mark it as visited. So this becomes array visited of ij. Visited ij equals to 0. We'll have a count variable for this particular island. We'll have int count equals to 0, and then we'll have a queue. Now, since we are actually dealing with the grid here, we'll actually have a queue of pair. Okay, so this becomes int queue, and now we will actually first insert this ij into this queue, and then we'll process all the 4 directions. So we'll first push q dot push make pair I comma j. Okay, and after this we'll have a while loop for all the 4 directions. So whenever we have something, so we'll first find out, we'll first pop the topmost element, which is actually, so this is the current element, which is q dot front. Now we'll pop this value from q. We'll have x equals to current, current dot first, and we'll have y equals to current dot second. Okay. Now we need to move in all the 4 directions. First, we'll actually increment the count as well, since we have processed one cell for the cell, and now we'll move in all the 4 directions. So if array I plus 1, this has to be x plus 1 y equals to 1, and this is not visited. If VIS of x plus 1 y equals to 0 equals to -1, and here we have to make it equals to 1. So if this is equals to -1, then we'll first mark it as visited. So x plus 1 y equals to 1, and we'll push this coordinate inside this queue. So we'll have x plus 1 comma y, and we'll actually do this for all the 4 directions. So let's say we have, okay, so the next coordinate can be x minus 1 y, x minus 1 y. We have x minus 1 y and x minus 1, this is, and x minus 1 y. Okay, the next we can actually move for y. So this will be y minus 1. So we'll have y minus 1. Again we'll have -1 here, and for pushing as well we'll have y minus 1. Then we can have x comma, what is left, y plus 1. We have visited of x comma y plus 1, and for these last values as well. Okay, I have the spelling of make wrong. I'll correct this now. So we have y plus 1, and now the spelling of make. Okay. Okay, and we have make. Okay. So I hope this is clear to everybody. So basically this is actually moving in the right direction, moving downwards. This is moving upwards. This is moving in the left direction, and this is moving in the right direction. Okay, now after this we'll actually, okay, so we have this as well. I think that's it for now, and we'll actually insert the count of this. So islands dot pushback into and this count, and we'll actually make a vector of islands as well. Vector. This vector is only to store the counts of every island. So we have inserted all the islands here, and after that, okay, we need to come out of. Okay, so basically this islands dot pushback is at its right position. Okay, cool. Okay, now we'll just sort this islands. Sort islands dot begin, comma islands dot end, and now we'll reverse this. Reverse begin islands dot end. Okay, cool. So now we just need to find the summation of all the alternate values. So we'll have an answer, and we'll just find the summation. So we'll actually start from 1 since we need the alternate values. Less than n I plus plus. We'll have answer plus equals to islands of I, and we'll increment I plus plus as well here as well. And in the end, we'll just print answer and then a new line. I think this is right. Let's compile this. I'll move the board for making it easier. Okay. So we have some errors. Let's look into these errors. Okay. The spelling of make is not right. Okay. Let's compile it now. This has to be Q. Okay, we have more errors. So this error says that Q dot push make pair x plus 1. Okay, there is a bracket missing at every place. Okay. What is happening? Okay, cool. Okay. So let's compile it again. We have more errors. Okay, cool. We have a typo here. This is islands. Okay, so we have 2, 1 and 1. Let's see where the mistake is. So the mistake is at this value. Let's try to print all the islands first. Okay. Okay, so I actually got the mistake. So the mistake is that we actually need to run it for islands.size. Okay, cool. Let's see if this works now. We have 4, 2 and 1, which is not right obviously. So I can see, let's try to print everything now. Okay, this starts from 0 actually. Okay, and let's print islands I. Okay, and after this, let's have a new line. So the output is 4, 1, and we have many ones actually. So we have 1, 2, 3, 6 ones. There is something wrong that we are doing then. Let's see how many ones we have. So we have 3 more ones. That means we are actually not able to visit these values. Okay. Did we miss it for -1? Yes, we did that. Okay. Let's print the count here. IJ. Okay, so we have 1, 1, 1, that is right. We have 1, 4, 1, that is also right. We have 2, 3, 4, that is right. 2 to 4, that is right. And then we have 2, 3, 1. So basically we are not able to visit any subsequent values. Okay. Okay, and we need to check here as well. If vis of I and j is not visited, and that is -1. I think this will run fine now. Let's comment everything. Yes, it's working right now. So we have 2, 0 and 1. Also, if you see, look into the problem, you will notice that we have, okay, we have an empt into the, okay, this is perfect. I think let's try to submit this now. And I hope this works. So we select C++ 17. If someone is still unclear about the approach and the implementation, they can let me know in the chat. And I'll just explain the parts again. Okay, so we have the correct answer for this as well. Okay, can people in the chat let me know if they're clear with this? Because the implementation was good, so I think maybe some people might not be able to get it. Clear. Okay, Vishal says clear. Perfect. Okay, so let's move on to the next problem then. Okay, so let's erase the board. Tish says clear, sir. Thank you. Okay, perfect. Perfect, Ratish. Okay, so I'll just bring the board back. Okay, perfect. So Sheffland is a 1D city where each of the n houses are located at distinct positive integer coordinates from A1 to AN. Okay. The chef is planning to create k hills in the city. Note that two hills cannot be present at the same location, but the location of hills and houses can overlap, and each hill will also be at any integer, positive, negative, or zero coordinate. Okay. Okay. Every citizen would want to travel to the farthest hill from his house. Traveling will create air pollution, and chef wants to minimize the total pollution in the city. Help chef find the minimum summation of sum of distances traveled by everyone. In other words, help chef create the hills at optimal locations so that the sum of the distance of every house to the hill farthest from it is minimum possible. Okay. Krishna says, is there any approach without using tree? Uh, basically we are not using tree. If you see, this is known as BFS, but if you see, we are actually working on a grid only, and we only have a queue here. So I don't say like we are using tree here, but yes, this approach is known as BFS, which is actually part of graphs only. So, but yes, the previous problem was a very standard problem, and I would actually tell everybody to like learn this approach because this comes handy in many places. Okay, cool. So if we see actually for this problem, we have three, what are these houses? I think uh, Chef Island is a 1D city. Okay, coordinates. Yes, houses. We have n houses. So we have for the very first test cases, we have 3, 1, 1, 2, 3. Okay, so we have a number line. Let's say this is 1, this is 2, and this is 3, and k equals to 1 here, and n equals to 3. So now we need to place one hill somewhere such that the distance of every house is minimum. So what if we make a hill here? The distances are actually going to be, so for 1 the distance will be 0, for 2 the distance will be 1, and for 3 the distance will be 2. Let's see what happens if I build the hill at position 2. The distance becomes, for 1 it will be 1, for 2 it will be 0, and for 3 it will be 1. So this was actually 3, this was 2, and for this 3, let's see the distance. So the distance is actually, for 1 it's 2, for 2 it's 1, and for 3 it's 0. So this distance is actually 3. So, okay, let's have the next example as well. So the next example says that 1, 5 and 1. So basically for this we can see that the minimum distance is 2 and therefore the answer is 2. For the next case we have 1, 5 and 1. So basically there is only one house at coordinate 1 and we need to make 5 hills. Okay, let's skip this one for a while. Let's come on to the next example. We have 2, 2, 1, 5. So basically we have two houses. This is 1, this is 2 and sorry, this is at position 5. So basically this is 1, this is 2, this is 3, this is 4 and this is 5. Okay, so and we have a house here at position 1 and position 5. Let's first try to have k equals to 1. If k equals to 1, that means we only have to make one hill. And let's see what is the total count for if we make the hill at house 1. Now the total count actually becomes, for house 1 it's 0 and for house 5 the distance is 4, so it's 0 plus 4. Now let's come on to position 2. Now for position 2 the distance for 1 will be 1, for 5 it will be 3. Now again for 3 it will be 2 plus 2, for 4 it will be 3 plus 1 and for 5 it is going to be 4 plus 0. Now we can see that this is 5, sorry, this is 4, this is also 4, this is also 4 and this is also 4 and this is also 4. Now let's see where should the other hill be for k equals to 2. So we can say that for k equals to 1 we can actually make a hill at any position. Now let's first forget that we actually had to make multiple hills and let's see how we would have made the hills if every time we had k equals to 1. So basically we have to find the coordinate on the number line which would actually give us the minimum summation for every house. And since the furthest, since we have k equals to 1, therefore that particular hill is always going to be the furthest hill from every house. Now can someone in the chat tell me what this coordinate is going to be? Okay, so let's see. So let's say that we will actually consider two cases, one when n is odd and one when n is even. Okay, let me just readjust my board. Okay, so if n is odd, that means this is of the form 2x plus 1. So let's say we have multiple houses, this is a number line and we have houses at every position. Now my say is that the minimal distances will be when we actually have the hill at the median of this. So by median what I mean is, let's say this is the median and by this we can say that this is one house and then we have x houses here and x houses here, because this is the definition of median. What median is, for every an odd number, the median is actually, for a sequence of odd values, the median is actually the middlemost element in the sorted order. So now since we already have sorted, because we have ai less than ai plus 1, every index is sorted, we can just say that the middlemost value is actually going to be the median. Now I'll just try to prove this. So first let's see the distance for this particular index. What is the distance when we have a hill here? So when we have a hill here, let's say there were four hills here, four houses here and four houses here. So basically our n right now is 9. Now the total distance for this is actually, so this house has a distance of 4, so it is 4. Then for this we have 3, for this we have 2 and for this we have 1. Now the distance for this particular hill is 0, so we have plus 0. Now let's see for the distance for this house from the hill. The distance is 1. Then from this house the distance is 2, from this house the distance is 3, and from the last house the distance is 4. And this total value is actually equals to 20. Now what happens if we shift this hill from this position to one left position? So let's say we had this number line here, and we shifted this hill to this position. Now let's see what happens. So if you actually see, the distance of this hill and this hill is actually going to reduce by 1, because the hill got shifted to their side. So we'll from the total answer we can see that we'll actually subtract -3, right? Sorry, not -3, for actually this position as well, because for this also we had a distance of 1, but now since the hill is at this particular index only, the distance will be 0. So we actually have -4. Now let's see what happened for these 5 values. We can say that the distance will increase by 1 for every house, because the hill shifted to the other end from their side. So for these particular 5 values, so for these 4 values we had -4, and for these 5 values we had +5, and the summation of both these values is actually +1. So basically this +1 is actually in total. So we can say that whenever we try to, and the same will be if we try to move on the right direction as well. So for left also we have total +1, for right also we'll have total +1. And with this we can say that if we ever try to move this hill away from the median, the distance will actually start increasing. And that is why we'll always consider the hill at the median. Now what happens if n is odd? If n is even? We have already considered this for odd. Let's see what happens if n is even. Okay, so if n is even, let's say this n is 6. We have 6 houses. Now we know that the hill should be at the median position, but since for even value we have 2 medians, one is this and one is this, where should we keep this hill? So let's try to calculate the distance for both the hills. If the hill is at this position, the distances are going to be, for this it will be 2, for this it will be 1, for this will be 0, for this it will be 1 plus 2 plus 3, and this actually becomes 9. And for this particular index we'll have the distance as 3, then we'll have 2, then we'll have 1, then we'll have 0, then we'll have 1, and then we'll have for this index 2, and this actually even comes out to be 9. So we can say that we can actually put the hill at any of the places and the result won't differ. So if k equals to 1, then we know that we actually need to put the hill at any of the median, and we will always have the optimal solution. Now what about k equals to 2? Okay, so for k equals to 2, since we know that the minimum value is actually, okay, let's try to I'll try to show this. So we know, let's say that we actually, for n equals to 6, if we had to insert one hill, we inserted it here. Now what about k equals to 2? Now the basic thing that we can say is we'll always have this particular hill somewhere consecutive to this hill, because having this hill, let's say we had the other hill here. Now the farthest hill for this particular index actually becomes this hill, and we can say that we are actually increasing the difference by 2. But if we put this hill here, we'll actually increase the distance by 1 for this index as well, and for this index as well, and for this index as well. Now let's talk about these two indexes. If the hill was at this particular index, this and this house will actually take the hill which is farthest from him, and for all the 3 indexes this hill is farthest. Therefore having this at here or here won't make a difference for these, but having this hill at this position will actually make a difference for these 3 houses. Therefore we'll always have the hills in consecutive places. So let's see what all things we know. So we know that for k equals to 1, we'll actually have the hill at the median, and we know that the hills are consecutive. Okay, okay. Now we know that we have one hill at the median. Let's say this is median. So this is median, and we have, so we now know that will actually the every house will actually take the farthest value. Now if he's going to take the farthest value, and we know that we have hills in consecutive way, so let's say that these are all the hills that we had. So for every house they will either take this hill or this hill, because they want to move in the farthest direction. So let's say we had a house here, and the farthest direction for this was this hill. We can always say that this hill will be farther than this hill, and this last hill will always be farther than this hill. So all we have to find is actually find the left index of the hills and the right index of the hills. Okay. So I hope this part is clear. Can people in the chat let me know if they're clear with this part? If they're clear with this, I'll jump on to the next explanation of this. Clear, sir. Vishal says clear. Atish says clear. Okay, cool. Okay. Okay. Now let's consider n and k. N and k. So we'll have two cases when n is odd. Let's say for n is odd, k can be even also. K can be odd, or k can be even. So for odd, this can be even. Now for even n, we can have k as odd as well, and we can have k as even as well. Let's consider the first case. Let's say we had odd n. So let's say we had 3n only. We had 3 houses, or let's just have 5 houses. And this is the median, and we have k equals to odd. If k is odd, for k equals to 1, we know that we'll actually put the hill here. If k is 3, we know that we actually need to insert the hills consecutive way. So we can just simply observe that the other hills will be one on the left side and one on the right side. The reason for this is because if we actually move on the right side only, let's say we had 3 hills here, the answer for this particular house, and this particular house will increase, whereas the answer for this particular house and this particular house won't even show any difference. But if we had this hill here, the distance of for this and this would be for this particular hill. Therefore we can say that let's say the distance was x, for 3 houses will actually have increased the distance by +3, because the next hill would be here, and the farthest hill for this and this would be this hill. That is why we'll always move one in the left, one in the right. So by this we can say that if k is odd and n is odd, then we will just take the median and we'll divide half k by 2 on the left direction and half k by 2 on the right direction. Now let's consider the next one. If n is odd and k is even, let's say, so now we know that k is even. Now an even k means we have 2 hills. Now for the first hill we know that we'll place it in the center, and the next hill we can actually place it here or here. Now the reason for this is actually because if we put the hill here, let's calculate the distance only. So the distance right now will be, for this particular hill, the farthest hill will be this one, so it is 2. For this hill, the farthest will be, for this house, the farthest hill is actually going to be this hill, so this becomes +1. Now for this house, the farthest is this hill, so this is +1. For this one we have +2. For this one we have +3. Now let's see if what happens if we replace this hill to this position. Now the farthest hill for this house actually becomes this hill, and the distance is 3. Now for this one we have the distance as 2. For this we have 1 distance. Then for this particular hill, the distance will be from this hill. So this becomes 1. And the next, for this particular one, this we have the hill, farthest hill as this one. So we have this 2 here. So let's see what is the sum of this. So we have 4 plus 3, 7 plus 8 and 9. And this is also same. So we can actually say that we can actually place the next one anywhere. We can even have it here, or we can have it here as well. Now what happens if this 2 is 4? Now we know that for 3, we will actually have to place one in the left direction and one in the right direction. So we are actually left with one more hill only. And from the previous example, when k was 2, we actually saw that we can actually have it anywhere in the left direction as well or in the right direction as well. So either place the next hill here, or we'll place the next hill here. So place at so we'll place this hill at any of the both places. Okay, so we are done with this as well. Okay, so Krishna says, please explain again the consecutive part. Okay, so let's see, say for this only, and let's say k was 2. Now we know that for k equals to 1, we'll actually have to place the hill here. Now let's consider 2 places, one when the hill is here and one when the hill is here. So let's first count the distance for this particular index. Now the farthest hill from this index is this hill. So we have 3. For this house, we have the farthest hill as this one. So the distance is 2. For this particular house, the distance is this hill. So we have +1. For this, we have this house. So this becomes +1. And for this, we have this only. So this becomes +2. And the sum is actually 9. Now let's see what happens if we shift this hill from here to here. Now the farthest hill from this house is actually this hill. So this becomes +4. For this house, we have the farthest hill as this one. So the answer is +3. Then for this particular house, this is +2. For this particular house, we can actually have this hill or this hill. So we can, and both the distances are 1 only. So we have +1. And for this particular house, the farthest hill is this one. And the distance is +2. Now let's see what is the summation. So we have 4 plus 3 is 7, +2 9, 10 and 12. Now as you can see, this is greater. This 12 is actually greater than this 9. Therefore, we'll always take, so basically what comes out of this is, we actually need to place the hills consecutively. Because after placing these 2 hills, let's say we had k equals to 3, we can place the next hill at here, here or here. But the optimal way will be to put it here, because we actually have to place it consecutively. So I hope this is clear to you, Krishna, now. So let's come on to the third case, when n is even and k is odd. So for let's take n as 4 and k as 1. Let's have a number line. These are the 4 places. Okay. And we have k equals to 1. Now we know that median is this and this. And for k equals to 1, we know that we can actually place the hills at any of the places. So let's say we place the hill here. Now what if k is 3? Now if k is 3, we know that we'll actually use the approach from the above one only. We'll start dividing these, one in the left direction, one in the right direction. So let's say we had one here and one here. That's it. That is the optimal way, because if we actually take, so basically one is this case. Now let's see what happens if we actually place this hill from here to here. We can say that basically this won't actually bring any difference, because so let's say we had this as 6 and the median was this value or this value. So basically let's say we had a hill here. Now what happens if k equals to 3? Now if k equals to 3, we know that we'll actually place the hills, one in the left direction and one in the right direction. Now what happens if we actually had placed the hills, let's say k equals to 5. Okay, yeah, k equals to 5. Okay, perfect. So we would actually have placed 2 in the left direction and 2 in the right direction. Now what happens if we actually took 2 of these and put it here, and let's say after this as well? You can see that the farthest cell for these two indexes would actually become these two. Sorry, the farthest cell would actually become this one, and we'll actually be adding +2 to the answer. And that is why we'll always have to take the median, have half of the hills on the left direction and half of the hills on the right direction. So we are done with this as well. Now let's come on to the last part. That is when both the things are even. Okay. 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 So let's say we had 6 values. 2, 3, 4, 6 houses. And so n is 6. Let's say k was 2. If k was 2, we know that since these two are the median, we can first place the first hill here. And now let's see where the next hill should be placed. Let's count the summation for if we place the next hill on the left direction of this hill. If we place the hill here, the count becomes, for this particular house, the farthest hill is this one, so this is 2. Plus for this one it's this only, we have +1. For this we have this hill for +1, then we have +2, +3 and +4. Now let's see what happens if we take this hill from this particular place to this particular place. So the farthest hill for this particular index is this one, so we have +4. Then for this house we have this only, we have sorry, this should be, I think I'm doing something wrong. So this is 3 actually, this is 3. Then for this one we have 2. Then for this one we have 1. For this one again we have 1. For this one we have 2. And for the next one again we have 3. So the summation of the above one is 2 plus 1 3 plus 1 4 plus 2 6 plus 7, that actually makes 13. And for this one we have 3 plus 2, this is 6 plus 6, this is actually 12. Now since this 12 is actually smaller, we can straight away say that we will always have the next hill on the side of the next median. So basically if we took this median as the first hill, then we'll actually place the next hill on the other side of the hill, on the other median side. But what happens if k is 4? Now we know that we have already placed one value here, one value here, and now let's count this as one part. So basically this k equals to 4 becomes k equals to 3 for now, and we'll actually have one hill here and one hill on the right direction. So we'll have one hill here and one on this direction. So basically what I'm trying to say is actually, so basically if we have a k even, then there are basically x, so how do I say this? So basically we know that one hill is placed on the center direction, so on the median. Now we'll have some values here and some values here. Now since this is even, so this will actually be of the form 2x. We have one value here, so basically we'll actually be placing x minus 1 values here and x values here, or we can have it other way, we can place x values here or x minus 1 values here. Now the optimal way for this will be to place more values on the direction of the other median, and the reason is because I just showed you what happens when k equals to 4. So we just need to make sure that, so basically in the above 3 parts we actually saw that there won't be any difference. We just have to place 1k and then we can have half on the left direction and the other half on the right direction, and the answer won't change. Then for even and even, we just need to make sure that whenever we place a hill on the median, we'll actually have more elements on the other median side. So basically, okay, so I'll just, let's say we had n and we had k. So the very first thing that I'm actually going to do is I'm going to find the mid, and this mid is actually going to be array of n by 2. Now for even, so let's say for n equals to 4, this mid will actually become, 2. And since it is a 0 based indexing, we'll have 0, 1, 2 and 3. We can say that we are actually on the right side of the median. So if we are on the right side, the next k is actually going to come on the left side. So all we have to do is, before on the right side, so basically we had to calculate left and right. Now if we know the mid, we just have to subtract k by 2 minus 1 from this, because we actually need, we need to subtract, k plus 1 by 2. And the reason for this is because, is this right? So we have mid, and so basically it will be k by 2 only. Because we are actually moving for 1, we have to do, yeah, okay, k by 2, because we actually need more elements on the left direction than on the right direction. I hope this is clear. I think this will actually get a little clear when I write the code. I'll just explain this part again when I write the code. So let's just write the code first. But I hope this is clear that we always have to have more elements on the other side of the median. So let's come on to the code. Okay, so let's parse this problem. Okay. Okay, cool. So do we have test cases as well? Yes, we have. So nt. Can people in the chat let me know if they're clear why we are taking more elements on the other median side? Okay, so the next thing is we have n and k. So we have n and k. Sorry, n and k. Okay, and now we'll just scan the array. Krishna says k by 2. Okay, I'll explain this k by 2 part again. But just let me know if you are clear with everything before that. Okay, 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 okay. Now let's see what is mid. So mid is actually array n by 2. Now, okay, I'll just erase everything. And let's have two cases, one even and one odd for n. So if n is odd, so let's have 5 values. This is 0, 1, 2, 3 and 4. Okay, cool. So okay, Astish says clear, and Atish says clear, and Vishal says for equal distribution of hills on right and left of median. Yeah, okay. Krishna says not clear. Okay, Krishna, just let me know if this becomes clear after this. So we have 0 to 4. Okay, so this is for odd. Let's have a case for even as well. For even,
Lawsuits instances
okay,
include attempts to overturn
so
the
we have
ruling
0,
of
1,
the
2,
state's
3,
presidential
4
election,
and
like
5.
Div-3, McDonald's restaurants, Apple Incorporated Group, Samsung
Alexa,
Electronics Company, Night
Alexa,
Horse Unlimited Group.
stop. Okay, so we have even case as well. So what happens when we actually do array n by 2? So basically for this n was 5 and for this n was 6. Now 5 by 2 is actually 2. This 2 is actually here, so we can say that we'll have one hill at one index 2. And for this, this is 6. 6 by 2 is actually 3. So we can say we are actually storing the first hill on the right median. Okay, cool. So we have median equals to this. And now we have to find the left position. So we'll have this equals to mid minus k by 2. Perfect. So, okay. Now I mentioned earlier that we'll always have more values on the left side of the hill, on the other side of the hill, other median side. So when n is odd, we can straight away say that it won't make a difference. We can just have, let's say, so basically since it was odd, this was of the form 2x plus 1. We have one hill here, so we can just say x, sorry. Now we actually have two cases here for k odd and k even. Let's consider odd. So if k is odd, this is actually of the form 2x plus 1. Now one hill is already at position 2. We can have x hills on the left direction and x hills on the right direction, and that is exactly what we are doing. So we have mid at 2, and then we do k by 2. So let's say if k was 3, k by 2 would have been 1, and 2 minus 1 would have been 1. So the left index would have become 1. Now let's see what happens if k is even. If k is even, we actually have this of the form 2x. Now one index we already have here. We will have x minus 1 on the left direction and x on the right direction, or we can have vice versa as well. We can have x on the left direction and x minus 1 on the right direction, and this won't actually bring any difference as we saw earlier. So let's see if this works for that as well. So if mid is 2 and k is what? K is, let's say, 4. If k is 4, so we'll have k by 4 by 2, that is, so let's say it, yeah, if we have 4, yeah, okay, if we have 4, so 4 by 2 becomes 2, and 2 minus 2 is 0. So basically what this says is we can actually have hills, one hill here, one here, one here, and one here. So this was the median. We took x minus 1, x places on this direction and x minus 1 places on this direction. We could have done it the other way around as well, but that wouldn't have made any difference. So we are done when when n is odd. Now let's come on to when n is even. So we can say that n is 6 here. So and since we are taking array n by 2, which is actually 3, so the first hill goes at this position. Now let's first see what happens if k is odd. If k is odd, let's say k is, so basically this is of the form 2x plus 1. Now we know that we have one hill here. We can straight away distribute x hills on this direction and x hills on this direction. Let's see if this lift is in line with this approach. So basically, let's say this k was 3. If this k was 3, we'll actually have to take one hill on this direction and one hill on the other direction. So so basically mid is actually 3, k is 3, 3 by 2 becomes 1. So 3 minus 1 is 2. So we can see that for this also this thing works, mid minus k by 2 works. Now let's come on to when k is even. If k is even, let's say 4. If k is 4, we already know that we have one hill on the middle. We can either have one hill here and two hills here, or we can have two hills here and one hill here. Now we already proved that the more number of hills are going to be on the other side of the median. We know that the other median is this 2, which is this direction. So we'll have more hills on this direction. So we'll have two hills here and one hill here. Now let's see if this is working for this case as well. So mid was 3, k is 4. If k is 4, k by 2 is actually going to be 2, and 3 minus 2 actually becomes 1, which is here. And if we have to ensure that we have two hills on this direction, we'll have one hill on 2 and one hill on 1. So we can say that this left is right. So we'll have the left index as mid minus k2. Now we know that the left index is this. Now let's try to find out the right index. We already know that all the hills are going to be consecutive. If they are going to be consecutive, we can just say that left plus k minus 1. This will be the right index. So we can just make as right equals to control Z, okay, right equals to left plus k minus 1. I hope this is clear to everybody. Now after doing this, all we have to do is find out the farthest hills from every house and just see find out the total answer. So let's say the total answer is this. So for int I equals to 0, I less than n I plus plus, answer plus equals to, now we do not know which the left is going to be the farthest one or right is going to be the farthest one. So what we are going to do is we are actually going to find the value for both the cases. So and take the we will take the maximum of both these values, since we are looking for the farthest hill. So it will be maximum of absolute of left minus array I and the other will be absolute of right minus array I. Okay, cool. Okay, and then we just print. Let's see if this compiles. Okay, this is 2 to 5. Okay, so this is working. Let's see the constraint. So we have the constraints as AI is less than equal to 10 minus 10 to the power 9. So we can say that actually this answer might go into the range of greater than 10 to the power 9. So we will have to put long at every place. So I'll take long and then just replace this end. Okay, so let's compile this. Okay, this is working. So let's just submit this and see if this works. Okay, so we need C++ 17, right? Okay. This is running. Let's see what happens. Krishna says getting confused. Okay, so okay, this is correct answer. So for the people who are actually getting confused, I'll actually tell an alternative approach for this. This approach is actually going to extend the stream a little, but I think many people might be confused about this. So I'll just have another approach for this one. Okay, do others also need another approach, or are they able to understand this one only? So I'll just remove everything, or I'll just remove the core part. Okay, so let's say we had all the houses on this particular line. Now we know that, and I hope everybody is clear of the fact that all the houses are going to be consecutive. So all the hills are going to be consecutive. So we can, let's say these are the hills. We can either have them here, we can either have them here, or we can have the range of hills here. These are all the possible places for the hills. Now what happens if, so let's say what happens, these can also be somewhere here as well, before this as well. So if we actually try to make a graph, we can say, and let's see this is the left position for everything, and let's try to count. So basically this is left, this is left. So if left is somewhere in the very negative direction, we can say that we'll have the maximum answer, because this actually will be somewhere before this, the all the houses. Understood, Abdul says understood. Okay, this strip is actually going to be before every house, and will always have a bigger answer. So let's say the answer is somewhere here. Now what happens if this strip is actually somewhere on the right side after all the houses? We can say that will have a similar very big answer. And what happens if this strip now starts moving somewhere in between the houses? We can say that our answer will actually start decreasing. Our answer will start decreasing, and let's say this was the most optimal way, then our answer will actually hit a low, and then it will again start increasing and reach the maximum on the left side. So as we can see, this is actually a U-shaped graph. Now since this is a U-shaped graph, we can actually have ternary search here. So what we can do is we can actually fix a left direction. Let's say we fixed one for this index, and let's say one was this index. Now we will see if the answer for this value is smaller, or the answer of this value is smaller. Now as we can see that the answer of this value is smaller, we can actually say that we for the next time we can actually have low and high, as low will be this, because we know that our answer is actually low for this direction. And so basically, just a second. Okay, so we have, let's say, so in the starting we'll have low as this position and high as this position. Okay, now let's see what happens for this particular answer. Now we know that for this particular left we have an answer which is lesser than this high, and let's see, there's one more point, which is this. Now we know that this point is actually a little below than this point. Now since this is below, we know that we can say that we might or might not. So basically we might get a new low after this, or this might be the lowest point of this graph. So what we'll do is, we know that there is no point in searching in this part of the graph. So we'll just take this low and shift this low here, right? Now we'll have a graph for this value and this value. Now we'll again have two more points. So let's say this point and this point only. Now we know that the answer for this point is what? This point is lesser than this point. Okay, sorry. Yeah, okay. So just a second. I'll just make this graph again. Let's say our graph was something like this. Now let's say that we took 2 points, one was at this point and one was at this point. Now we know that the answer for this point is lesser than the answer for this particular point. So basically this is 1 and this is 1 left. So this is our point P1 and this is point P2. Now we know that the answer for this, so the answer for P1 is lesser than answer for P2. So what this tells us, actually we are actually moving upwards when we move from P1 to P2. So by that we can say that there is no value after P2 which can be the answer. So what we'll do is, we'll actually delete this part of the graph. Now we have this graph. Now let's take two more points. Let's see, we have this point and we have this point. Now we know that, so basically now this becomes P1, this becomes P1 and this becomes P2. Now we know that answer of P1 is actually greater than P2. By this we can say that we are actually decreasing our answer when we move from P1 to P2, and by this we can say that there is no point before P1 which has our answer. So what we can do is, we can actually delete this part, and by this you can actually see we'll keep on decreasing the curve until we find a point which has the lowest answer. So this is known as ternary search. If you are not familiar, you can just Google it and learn about this a little more. But we are actually going to write a ternary search code. So basically what this saved us is, we didn't have to check all the cases like we did in the previous approach. We had to check four cases and then see like what was the best answer and how the indexes would move. In this particular approach, we can just use a very simple ternary search algorithm. So I'll just write the code for that. Okay, so I hope this approach is clear to everybody, and people can let me know in the chat if they are still not getting confused. I'll just write the code. So let's have this long somewhere outside now. Okay, so we have int low, not int, we have long low equals to okay, let's say this is somewhere negative, because we can have negative houses as well. So this was minus 1e9. Okay, then we have low high equals to positive 1e9. So we have positive 1e9. Okay, cool. And now let's just run this for ternary search. While okay, high minus low is actually less than 2. Sorry. So while this is the difference between these two values is greater than 2, we'll have 2 points. Let's call them m1. So this is m1. So let's have these as m1 and m2. So this is m1 and this is m2. So we have m1 equals to, or let's have a diff first. Int diff equals to, okay, so the difference is actually going to be this plus this by 3. Okay, so we have high minus low by 3. Okay, now we'll have int, sorry, this has to be long mid. So m1 is actually equals to, sorry, low plus diff, and long m2 is actually equals to high minus diff. Okay, now we check if Okay, answer for m1, sorry, m1 is less than answer for m2. If this is like this, then we actually replace low as m1. Okay, we actually replace low as m1 minus 1 or m1. Okay, this is right. Okay, so if okay, so we'll just no. We actually have to replace high here because we know that there's no point in moving beyond m2. So we'll make high as m2, else we'll make low as low as m1. I'm still waiting for people to reply in the chat if they are able to understand. Okay, Krishna says clear, very nice. Okay, can others also confirm? Okay. Okay, so let's write this answer function now. Int answer. Oh, sorry, answer. Okay, int x. This is the position where we are at. Okay, so, and we'll actually make it as the left since we have right as well. So now we already have left index. We'll just find the right index. Right is going to be Vishal says clear, Atish says clear. Very nice. Okay, perfect. So we have right as k minus 1, and now we'll just run a loop for int I equals to 0, I less than n I plus plus. We'll just have answer. Sorry. We'll have f answer equals to maximum of we'll have absolute value of array I minus left, and we'll have absolute of array I minus right, and then we'll just return this if answer. And we actually need this array as global now. So we'll just okay, make it global. Let's see the maximum size of everything. So the maximum size of array is 10 to the power 5. So we make this n as somewhere around 10 to the power 5, and we actually cannot have an array named array as a global array. So we'll make this arr. Okay, this becomes arr and this becomes arr. Okay, cool. I think everything is perfect now. Okay, cool. We actually need to declare this f answer as well. So f answer equals to 0. We need this as, we'll replace all ends with long in the end now. Okay, now we actually have, so if you see, we have high minus low greater than 2. So basically now we have a low and a high, and these are actually consecutive, because if they're not consecutive, so sorry, they're not consecutive, the difference between these is maximum 2. So basically they are the maximum difference. So basically it is this. So this is low and this is high. Now all we'll do is we'll actually check if, now we need to find out which out of these three places has the lowest answer. So for doing that, what we'll do is we'll actually find the answer for all the three places, because these are only three and we can do them in constant time. So for int I equals to low, I less than equal to high, I plus plus. Okay, and now we'll have int left equals to I, int right equals to I plus k minus 1, and then we'll just have this particular same thing only. Should we? Okay, cool. Okay, and before that we'll have an f answer as well with 0. Okay, f answer equals to this, and we'll have this as answer now. Int answer equals to 0. This is answer. Now we'll just replace f answer equals to minimum of f answer comma answer. f answer comma answer. I hope everybody is able to understand the code, and then we'll just print f answer. Let's see if this works. I hope it does. Okay, I think everything is perfect. Let's try to run it. We have errors. Okay, let's look at the very first error. So we have f answer equals to maximum long to int. Okay, cool. So let's just replace every long with int first. Now Abdul says first approach was easy. Okay, I personally feel that first approach was easy because that's a little bit intuitive. But for people who are not able to get that, and since we are in a contest and we need to do things fast, we can actually think of this ternary search because it can be implemented very fast. Answer cannot be used as a okay. We already had an answer, so let's have answer 1, and answer 1. Okay. I think we have a runtime error. Yes, exactly. We have a runtime error. Okay. Let's see the issue. Okay. Low is minus 1e9. Okay. High is 1e9. High minus low is greater than 2. Okay. Diff equals to high minus low by 2. That is right. Oh, sorry. This is, yeah, high minus low by 3. Okay. Then we have low plus diff. We have high minus diff. Okay. Perfect. Then we have if answer of this is less than this, then we have high equals to m2 and low equals to m1. Okay, so I think this should pass. Let's see where it fails. So we had 1 to 3. Oh, where are we even using? Just a second. Okay, this is this. Okay, I think this is correct. One, 1, 2, 3. Okay, let's see where it fails. So when we have this, okay, so let's try to print. Will printing help? Slow is good. Okay. Okay, let's do one thing. I'll not waste much time right now. I'll just fix this code after the stream and I'll submit this, and you can just find it from my submission, because I think we are already at 108 minutes and I have to end the stream in 2 hours, and we are still left with the hardest problem of this contest. But to be honest, I don't really see like where we are doing wrong. I'll have to debug this. Okay, okay. Okay, met is low plus def, m2 equals to high minus def. Okay, answer is m1 less than answer of m2. Okay, cool. Okay, answer minus left. This has to be absolute. Let's see if this works. Although this wouldn't bring any difference. We have 0, 0, 0. Okay. This has to be int max. Or let's have it INF. INF was not declared. Okay, I don't have it here. Let's have 1e50. Okay, so let's try to compile this. We have 2, 3 and 5, so it is not working for the second case. Let's see. Okay, let's see what was low. Yes, next. Okay, Krishna says yes sir, next question please. Just give me a minute. So left is not, oh sorry, low. Vishal also says yes sir. Okay, people are saying yes sir to switch. Okay. Okay, so low is -2 actually, and the high will be 0, line 52. Okay, what even am I doing here? This has to be. Thanks, Vendalu. I don't know if I pronounced your name right, but this is a very big mistake that I did here. So this has to be J, and this will be ABS. Okay, multiple mistakes in this code. Okay, now it's not right at all. Wait just a second. Let's see the answers. 0, 2, and 1. Okay, very bad. Answer 1, answer 1. Okay. Can someone help me out in the chat? Maybe people in the chat can tell me what silly mistake I'm doing here. Okay, this has to be answer plus equals to. And this has to be answer plus equals to. Okay, we have 2, 2, and 5. Let's submit this now. I hope everything is long. Yes, perfect. Okay, C++ 70 and submit. Okay, correct answer. Perfect. Let's move on to the next problem. That is aka the hardest problem of this contest. Okay, the name is cleaning drive. Okay, so I personally feel that cleaning drive is easier than the previous problem. Okay, there's a hallway of length n minus 1 and you have m workers to clean the floor. Okay, each worker is responsible for segment LR, LI, RI. The segment starting at LI and ending at RI, the segments might overlap. Every unit of length of the floor should be cleaned by at least one worker. A worker can clean 1 unit of length of the floor in 1 unit of time and can start from any position within the segment. Okay, a worker can also choose to move in any direction. However, the flow of each worker should be continuous. They cannot skip any portion and jump to the next one, though they can change the direction. What's the minimum amount of time required to clean the floor if the workers work simultaneously? Okay, so basically what they are saying is we have a hallway of length n minus 1. So basically we have n points. And let's say we had m workers. So first worker did this, second worker did this, third worker did this, fourth worker did this, and the fifth worker did something like this. Okay, perfect. So what they're trying to say is that let's say we are this worker. This worker can actually start at any point. It can start here, 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 or here, or here. But once he starts moving in one direction, he cannot jump. So let's say he started from this direction. He could have moved in this direction first. So let's say he came to this direction. And now he cannot skip this position and just move directly to this position. He first has to clean this position, or he can go backwards. Now going backwards, if we see, is not optimal, because if he goes backward, he's actually going to waste 1 second here. But what he could have done is he could have actually started from this particular index only. He could have moved first here, then here, and hence in 2 seconds, in 3 seconds, he could have been able to clean 3 points. But if he would have started from this particular index, 1 point for this index, second for this index, then third second for coming back to this index, and then fourth second for going to the previous step. So basically what we can say is every worker, and it actually means the same to start from here or to start from here and then go in this direction or in this direction. So basically what we can assume is for every worker we actually have to find a starting point, and then he will move from that particular point to the right direction. Now we can also say that he will actually find a starting point and move in the right direction only. But if you see, both the things are similar, because if he moves from this direction or if he moves from this direction, both the things are going to give us the same answer. So what we know is for every worker we have to find a point from where he starts, and then he will only move into the left direction. And now what we need to do is we need to find out the minimum time. So the very basic thing we can actually see is, let's say we are given a time t, and we can check if every worker is able to simultaneously work and complete all the n indexes and clean them. If yes, we can say that answer might exist for something less than t as well. So we'll just take if an answer exists for something below t as well. So as you can see, we are actually using binary search, a very basic binary search here. And now let's come on to, let's say we are given any time frame t. And now let's see how we are able to, how we are going to check if all the workers can simultaneously work and clean all the floors in the given time frame t. So is this binary search, why binary search is going to work here is clear to everybody. Can people in the chat let me know? Okay. Krishna says optimize the time. Yes, that is exactly what we have to do. We have to find the best time in which all the workers can work simultaneously and clean every floor. Vishal says no. Okay. So basically, let's say somehow we were able to check that for a given time t, for a given time t, all the workers were able to clean this. So basically, okay, let's have it this way. Let's come to the previous example first. So let's say this is t. T stands for time here. Okay. So now we know that for a very large time, we already know that they will be able to clean the floor. Okay. So this is 0, this is 1. 1 stands if they're able to clean the floor, 0 stands if they're not able to. So we know that for a very large time, they will be able to clean the floor. Now, since they are able to clean the floor, we can say that maybe 1 second before that also, if we gave them t minus 1, they might have been able to clean the floor. And by doing so, we can also say that an optimized time will come, in which a time will come when every worker worked in the most optimal way. And so let's say if this was t, we might be able to say that in t minus 1 they were not able to clean all the floors, but in t they were able to clean the floor. But if they were able to clean all the floors in t second, they will also be able to clean the floor in t plus 1 second, because they can just sit idle and as the floors are already clean. And same for the other cases as well. So we can say that for every point after this t, everybody will be able to clean the floor like simultaneously, and every point before this t, they will not be able to clean the floor. Is this clear to everybody? And to do this, we actually have to use binary search. Understood, sir. Vishal says understood. Perfect. Okay. Okay, clear. Krishna says clear. Atish says clear. Okay, perfect. I think it's clear to everybody now. Okay, now let's move on to the next step. Now let's see how we are going to calculate this. For a given time t, how are we able to calculate if every worker was able to clean the floors or not? So let's say we were given a time, let's say 3 seconds. Now we know that since we have to clean the floors from the start, whenever we come to this, we'll see how many, so we are at this particular index now. We'll first see how many workers before this time or at this time can start working. At this index, before this index or at this index can start working. Now we know that there is only one worker. So we'll say that, so this is worker number 1, 2, okay, let's not number them. Okay. So we know that this worker can start working, and then for the next 3 seconds, he'll be able to clean the floor for these 3 indexes. Perfect. But, okay, yeah, for these 3 indexes. Now we need to see how many people did he overlap with. So he overlapped with this index, he overlapped with this index, and he overlapped with this index. Okay, but now we already know that there is no point of using this particular worker because he is overlapped by this worker. But this worker can actually make use of the floor that the above one clean, and he can now start from this particular index. And the same goes for the below index. He can actually start working from this index, and he can also start working from this index. Now we'll again see how many of these are actually able to extend to next time frame, which is t plus 3. So if this is t, how many of these are actually able to, how further are they able to go? So this worker is only able to go 2 steps, this worker is only able to go 2 steps, and this worker is only able to go 2 steps, 3 steps. So we can directly make use of this worker and say that he will be able to clean all the floors from this index. Now let's say if this t was 2, if this t was 2, I'll just clear this image. Okay, so we had one here and one here. Okay, if this t was 2, we might have used worker number 1 to clean till this floor. He might have cleaned this floor and this floor, and he would have come on to the next floor that he had to clean, that we had to clean, was this one. Now this worker doesn't have any use. Then now let's come on to, now let's see that we can actually assign the next work to this worker or this worker. But the optimal way will be to assign 2 steps to this worker. So he'll clean this and this. Now a current coordinate will become this, that we now have to start cleaning from this index. Now we can see that we can actually assign the next work to this worker or this worker. We'll assign the work to this worker. He'll clean this floor, and he'll the answer, the next index will become this one, that is the last one, and then we'll ask this particular worker to clean this floor. So basically the optimal answer for this will be t equals to 2. For t equals to 1, if you'll see, we will not be able to find the answer. Now in order to implement this, we'll actually have to make use of multiset, I think. Not multiset, we can actually, so basically the very first thing that we'll have to do is we'll have to sort all the workers in according to their li and ri. So first we'll take li, and then we'll sort them according to ri. So let's start writing the code, and I'll try to explain the approach and implementation of this while writing the code. So the major part in this problem is actually the implementation. The logic is pretty simple, I would say. Getting to know that binary search will be used is pretty simple, but how to check for a given time frame that we will be able to complete the job or not, that is the main question. Okay, so let's pass these problems first. Okay, cool. Let's have the template. Okay, so we are given number of test cases first, so let's have them t minus minus. Okay, and the next is each test case contains m plus 1 lines of input, that is every worker. Okay, I think the first line contains 2 spaces nm. Okay, so we have int nm cin nm. Okay, each of the next n lines contains 2 space separated li ri endpoints of the segment under. Okay, so we have m plus 1 values, I think. Yeah, m plus 1 or n plus 1. Each test case contains m plus 1. Okay, every test case contains m plus 1 lines. Okay, perfect. Okay, so basically for int I equals to, now for every worker we will have li and ri. Now to store these, we'll actually have a vector of pair. have pair intent, and this is time, I would say, and then we'll just have x and y. So int x, or we can say L comma R. Let's, yeah, L comma R. This is scene. Sorry. Okay, we will scan L and R. So we'll have scene L, scene R, and then we'll push every time into the time. So we have make pair L comma. Okay, cool. And after this, we'll sort this time. Sort time dot begin. Okay, and we'll have time dot end. Okay. Okay, cool. So let's say we had a multi-set for this as int multi. Okay, we'll have int current equals to 1. Then we'll have while. So basically we'll have this current value go till n while this is less than L. And now we'll have this while. Okay, this while, then this will have, so we are at B. Okay, we will also need an index for that as well. Okay, so if time, let's say I only for now, dot okay, time I dot first is less than, so this n is actually total number of, okay, floors. Okay, perfect. So this n is total number of floors, and then we have an index. So we'll have an index, let's say for index 0 is less than, so this is actually index only current. If this is less than current and index is less than, index will be less than the size of that is m, right? If this, then we'll actually increment index plus plus, and we'll also insert these values into a set multi dot insert, and we'll just insert the second part of the value, so dot second. Okay, so this is cool. After this I have a value int value equals to, now while, okay, this value is less than equal to current and okay, so while this is less than equal to current, and I always have something in the set, so multi dot size is greater than 0, this will be typecasted to int. Okay, if this is greater than 0, then I'll just replace my value with I suppose multi dot begin will have the value, so this is the pointer, so I'll have the value at this. Okay, and I'll now erase this multi dot begin. Yes, I'll erase, so I'll erase multi dot erase multi dot begin. So what I'm actually doing is, let's say I was at this current index. Now I'll see, let's say I was actually at this index. I'll try to see how many workers I had who had a start time before this, because these are the workers that I might assign the next task to. So I'll have all of them somewhere in this multi. So in this multi, I'm actually storing the endpoints of all these workers. Now I'm actually checking how many of these, okay, now I'll actually see how many out of these workers have already exhausted their value. So basically whose RI is less than this. Now the very second I get somebody's RI as less, so let's say I got 3 workers who actually had their LI before this particular index. So let's say this is R1, this is R2, this is R3, and I actually used R1, R2, and the endpoints of all these three workers into the multiset. Now I'll explain why I'm using a multiset. So since this is a multiset, it will actually get automatically sorted. Now if this is sorted, I will see how many people out of these were actually exhausted. So by exhausted I mean is, let's say for this worker, I know that he has already used his time. So basically he can always clean the floors before this index, not at this index. So let's say this was R1. So there is no point of having this R1 and this multi. Now I'll have R2 and R3. Now I know that R2 is less than R3. So I will actually try to see how much R2 I can use, because this R2 is actually inside R3 as well. So I'll try to use R2 first, so that I'll have to use minimal R3, because I have a limit of time t and I cannot use any worker for more than t seconds. So that is what I'm doing. So this value is actually going to contain the value of R2 now. So now what I'll do is I'll actually update. So I'll update my current value as minimum of. So I'll have time as, okay, so we did a mistake. We actually forgot that we have to also use binary search here. So okay, let's say that it was t. So we'll just write the binary search code here. But before that, let's say this was t. Like we had to check for a time t. So this will actually be minimum of, okay, current plus t, comma. So basically if he is at this current, he can actually move to current plus t, because he can actually have workers work for the next t seconds on this particular task. Or he will actually have to see if this R2 is smaller than that or not. So this will actually be value, I think. Yes, value. Okay. Right, perfect. I think this is right. Okay, this is this is this. Okay, yes, I think this is correct. Okay. Okay, now let's first actually write the binary search. So int low equals to 0, int right, sorry, the least time can be 0. Okay, that's not an issue. This is 1e9. I think 1e9 will work. This is 1e9 working? Just a second. Okay, so we can have 1e9, but I think the better option will be to take n, and I think this will be 1, because we can at least have for 1 second we'll at least have to check. Okay, so okay, while this is, okay, let's have it as low and high. The TikTok says you're working. Thanks TikTok. Okay, we have while low is less than high. I will have int mid equals to, so mid will be low plus high by 2. So low, okay, low plus high by 2. Okay, and now I'll just check for this. So okay, this part of the code will actually be cut, paste here. I hope the approach is clear to everybody, like why I'm doing this R1, R2, R3 thing. If this is not clear, people in the chat can let me know. I'll just explain this again. Okay, so we have mid equals to this, multi equals to this, and then this t will actually become mid. And now we'll see, okay, we actually need to ensure that this does not go wrong. Okay, we'll do that later. If this mid, sorry, if current equals to n, that means if current is greater than equal to n, let's say, or this will be equal to n only always, max. If current equals to n, then we can say that our answer is what, mid, else and low will become. So basically we were able to do for this. So basically high will become mid minus 1, else low will become mid plus 1. And let's have a global variable for answer, and let's print this at the very end. So this will the minimal time. Okay, so people have clear. Shubham says audio volume should be increased. I'll try to make this better next time. We have okay. Okay. Okay, so I think we are almost done with the code. Let me just take it again. Okay. Okay, just a second. Okay, so we had index equals to 0, time of index. Okay, current was 1, current less than 1. Okay, we are at the very first index right now. Then we say if index equals to 0 while time of index dot first. Okay, so time of index, this is not right, I think. This has to be outside. Okay, if time of index dot first is less than current, if anything started at this point or less than at this point as well, so this will be current less than equals to. So if time index dot first is less than equal to current and an index is less than and an index is less than index plus plus. Okay, multi-set insert. Okay, perfect. I have int value equals to 0. Should I clear this as well after? No, there's no point of clearing. Okay. Okay, I think there might be. So int value equals to 0 while value is less than equals to. Okay, perfect. And then we have multi-set dot size is greater than. Okay, we have this dot erase this. Okay, I just need to insert an ending condition. So if this index, no, not index, if this value is still less than current, if this value is less than current, less than equal to or less than, this, I'll just remove this. So for removing, I'll do, so basically by this point I can say that I do not have an answer. So I'll try to break from this. If I break, it'll come outside of this while loop. I will see if my current will obviously be not be equals to n. Okay, so if value is this, I'll just break out of this and I'll update my current. Is that right? Yes, this is right. Okay, I think this should run. Let's try running it. We have couple of errors. See how to answer. Okay, so this is wrong. Compile and run. The next thing that we have is, okay, begin spelling is wrong. Okay, let's compile and run this. Okay, we also have -1 as an answer. When do we have -1? So we have 888. Okay. When do we have -1? For you say outward to clean the hallway or -1 if it is not possible. Okay. Okay, I need to also ensure that it is possible or not. Okay, that can be done through answer equals to -1. If answer equals to -1, we can just make answer. Okay, so the answer will be -1 only then. Okay, cool. I think that is handled. And we have 8 for every test case. I think I'm not scanning. Okay, we have -1. Okay, so now let's see for the above two cases. Okay, low is less than high. Okay, just I have Krishna saying audio is very low here. Okay, I'll work on this audio next time. Okay. So we have value lesson. Okay. Mm, I have med -1, med +1, so I can even have this low less than equals to. The next thing is this. Okay, multiset. Okay, I have a multiset. I have a current pointer. I have an index equals to 0. Okay. Now while this current is less than n, time of okay, okay, cool. This is right, I think, and this is less than n. This is right, I think. Index plus plus multiset dot insert. Yes, this is right. Okay, then I have value equals to 0 while value is less than equals to 1, and while I have something in this, I'll just pop the value. I'll erase this particular value. I'll have value less than equals to current break, current plus equals to current plus mid. Okay, I think there's some issue with this line because everything apart from this is right. So if we can move this many times ahead, or okay, this will, sorry, this has to be, this is wrong. Okay, still not right. We have 9 minus 1 and 9. Okay, so we have current plus equals to if mid works or value, minimum of value. Okay, so current equals to this or minimum of current plus this is right. Okay, so we have 5 and 9. I think there is some small mistake now also. Okay, let's try to figure it out. The current, let me check if I have any comments. Okay, cool. So we have current equals to min plus current plus mid. That is right. We had t seconds. We will move to that particular second, right? Okay. So this actually should be n plus 1, I think now. Okay. So we were actually able to clean till this particular value. So we saw if we were able to clean till this particular value. Okay, so this should be -1, current plus mid -1, and then I should have current plus plus. That we were able to clear till this value. Right, exactly. So we were able to clear till this value. But the maximum length that we can cover in one instance, okay, this should not be value. This should be actually minus of current, because we are actually at current. So from current, let's say, okay, so let's say I'm at 3 and we can have this at till 5. So we'll have 5 minus 3, that is 2. But we're actually, okay, so this will be, okay, plus 1. This is the total length that can be cleaned right now. And this is the length that is the total time that we, okay, I'll just have this and then we'll have current plus. So, and this is the total seconds that we have. So basically, if we are at 3 and we can actually clean 3, so 3, 4, 5, yes, exactly, and then current plus this. I think this will work now. Okay, so we have value ones. Okay, I'm actually very so I had to stream for 2 hours only and we are actually running out of time. So I'll just do one thing. I'll submit this code right after the stream so you can see it. I hope the logic is clear to everybody. Okay, and okay, I'll just spend a minute more and try to work this out. Okay, so I had this, okay, this, okay, okay, uh, So I had a multi-set, I had current equals to 1, ptr equals to 1, okay. Current less than n, time of this of first is less than, okay, perfect. Till I can make things, I will have things, okay, insert plus index plus plus, okay, have, okay, this is cool, okay. I'll pop that element, okay. Okay, this actually will be on plus 1, I think now. Let's see. Okay, somewhat right. If okay, because we are actually making current equals to n till here, and then we have to go n plus plus. What if n becomes n minus 1? For n minus 1, I'll actually run all the loops. I'll make it reach till n. I'll have n plus 1. Okay, while current is less than equal to n. Okay, so here's what I'm going to do. I'll just submit this code right after the stream. I'll just figure out this problem with this approach and I'll submit. But I hope the approach is clear to everybody. Yeah, I guess that's it.